All right, let's try it again. Class.
Yes.
All right, you people, thank you for all that have showed up today. If you have not showed up, you better be watching this video online.
Bro, and then we're missing her and acid.
Yep. All right, anyway. Satellite traveling in a circular orbit 1,600 kilometers above the surface of the Earth. Takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers.
That's true.
Always, radius of the Earth, on all these problems, 6,400 kilometers. Okay? So, approximate the linear speed. Linear speed. So, what variable is that if I'm looking for linear speed? That's the v. That's my velocity. All right, so let's take a look. It says, okay, right here, this is the information given to us from here out to the orbit. So that's going to be the radius of the circle, isn't it? Say yes.
Yes.
Okay, so R
This is example 3.
is going to be what value?
Oh, because you were here yesterday. Hold on, we need a little copy of 3.4.
12.1? How'd you get 12.1 for an R?
What? No.
Oh! Okay. Yeah, that's probably why. The other class's notes.
Oh. Why are they on unit 12 already?
They use a different book.
Oh.
And so since their discrete book is actually, the discrete class is a two semester type thing. So the book is second semester. So we start at chapter 7 and go through 18.
What do you mean is discrete? Like where? So that's just like
It's college math.
College math.
Yeah. So 151, that's college algebra. Make sense? Yeah.
Yeah.
Okay, anyway. So R would be from the center of the Earth to the orbit. What is the radius?
Center of the Earth to the orbit. That's no, it's they combine them 6,400 and 1,600 now.
Which is going to give me
8,000.
8,000. 8,000.
You're adding those,
Yeah,
Why would you subtract?
because we're going to tunnel through the Earth.
Oh.
And we're going to make that. All right. What else do we have?
right? The surface of the Earth is 2 hours.
Yes, it takes 2 hours to make an orbit, right? So one orbit, okay, it's going to take 2 hours. So that means that one orbit is 2 hours.
Which one is
So it is going to be,
that? Which variable is that? T R whatever L.
one orbit is 2 pi, isn't it?
Yeah.
And it takes 2 hours. What do you think an angle divided by time is?
Angle divided by time.
You could look back in your notes. You don't have to try and pull it out of your brain. Look back on the notes.
Okay, you said an angle divided by time?
Angle divided by time. Very good. It's W. It's my angular speed.
Oh.
Because it takes one orbit in 2 hours, I could use that information and say that's my W. So I could reduce that, which is going to give me pi hours, right?
Yes.
And that's rad per hour. Now, so again, what are we looking for? What variable are we looking for? V. The linear speed is V, right? Now, what two things I have now? I have R and W. Is that enough information to solve for V?
Yes.
Very good. So that's going to be a yes. So I would say V is equal to RW. V equals R, which is 8,000. And W, which is pi. So my velocity is going to be 8,000 pi. What are my units?
Oh, hold on.
Kilometers per hour. Kilometers per hour, because velocity is the distance over time, right? And radius, which I got here, radius is in kilometers. So this is km per hour. Not too bad, right? That's actually going pretty fast, isn't it?
Can you go over like what the variable stands for?
There you go. Okay. Angular speed is W, right? Angular speed is W. And that's going to be the angle divided by time. Right? Angle divided by time. Linear speed is my velocity, which is V, which is distance over time. S is my distance. T is my time. Let's keep going. Again, velocity. R is my radius. Theta is my angle, but in what mode? Radians. Okay, these are my angle in radians divided by time. And then my last one, velocity, is radius times W, which is my angular speed. Does that help you out? Good refresher? Okay. All right. So now, let's take a look. It says approximate the distance the satellite travels in 4.5 hours. Okay, so I know my velocity right now. 8,000 pi, and that is km per hour. And that's for 1 hour, right?
Yes.
What would I do to figure out how far does it go in 4.5 hours? Multiply by? Very good, that's it. Just multiply by 4.5. So let's say, for instance, we have Kevin. He's driving through the school zone, okay, right there, and he's doing 45 miles per hour through that school zone, right? If that school zone is 2 miles long, you would hit 90, okay? You would have 90 miles there, right? So let's go ahead. So I'm going to take that and multiply by 4.5 hours. So the distance, and let's do this. So my distance in 4.5 hours. So actually multiply it out for me, please. And actually multiply the pi. Put the pi in there also. Yes.
113,097.
And that's going to be
Kilometers
in,
in 4.5 hours.
yep, in 4.5 hours. So think about it in rotations too. So if it takes 2 hours to make one orbit, one rotation around, so it's actually in that 4.5 hours, it's gone around the Earth more than twice.
Yeah, I think quite a bit more than twice.
Yeah, but still, that's 2 whole rotations. And just to let you know, that is a lot faster than the speed of sound.
Yeah, that's the one.
But in space, they cannot hear you scream because there is no sound. It's in a vacuum. I don't know. It's a bad movie quote, I guess.
Where did that even like come from? That quote.
I think it's from like the original Aliens. In space, they can't hear you scream.
Oh, I think it was like a slogan for they used in movies to promote it or something like that.
Yeah, something like that. Yeah.
The first one was good though. The first Alien was pretty good. The second one was pretty good. Every movie after that though, it was just worse and worse.
Yep. All right. You know what that means?
It means we're gonna talk about Playboy Cardi's discography.
Oh, you're disgusting. All right, so like, share, and subscribe. Hit that notification button and support my channel. Dropping new socks. I didn't do it this last weekend, but still working on that design.